Hi students, this is Mrs. Gifford with a lesson on reviewing combining like terms that have just numbers and variables. So just remember, you're going to set your paper up in Cornell Note style. So you're going to draw a line down the middle-ish to maybe 1/3, 2/3. On the left-hand side, this is where we put all the questions, and on the right-hand side is where we're going to put the notes and the work. So after this lesson, you should be able to combine like terms involving numbers and variables. Remember, at any time, just pause the video anytime that you need it, and then you can rewind and play again as many times as you need to. So here's our first vocabulary term. So what you want to do is grab your vocabulary section, whether you put it in a notebook or in a packet, and go to the L page of your vocab and write down like terms, and then we're going to define it as an algebraic terms that have the same base and same exponent. This can include both numbers and variables. Again, this is key, same base and same exponent. So let's move into our first examples here, and we're going to combine like terms. And if you look at this first one, it actually is pretty straightforward because you probably notice that it has just numbers in here. And so all we're going to do when it's plain numbers like this is simply add it, and we know that 2 plus 4 is 6. No variables to worry about in this one. Same thing in example B. We have a negative plus a positive, and we just got done reviewing positive and negative numbers. And so this is going to end up being a positive 5. Again, there's no variables here for us to even worry about. Example C is just a little bit different. Now we have variables, and we just talked about being like terms having the same variable and the same exponent. X is here in both of them, and they each have an imaginary 1 as the exponent. So we can go ahead and add those two together. And anytime you have a plain variable, we need to think of the coefficient being an invisible 1. 1 plus 1 is 2, so 1x plus 1x becomes 2x. In example D here, do you see the same variable in either part of it? No, we don't. So there's actually nothing that we can do to simplify this even any further. So you could say this can't be simplified, there's nothing we can do, or simply just rewrite it as is. Maybe I should erase that. All right. Example 2, we're going to continue combining like terms, and we're going to start with letter A. And again, we look for the variables, and then we look to the exponents. And to be honest with you, in this lesson, we're not doing anything with exponents, so you simply have to look at the variables. Here we have 3x and 5x. There's no other variable in here, and so we know that our answer is going to have an x in it. And then we can simply take what we just reviewed with integers and do -3 minus 5. And if you need that reminder also, you could change this to adding a -5. And what does that become? That's right, it becomes -8. So -8x. When we add and subtract terms, we don't do anything with the exponent. The only time exponents change is when we multiply or divide them. So looking at example B here, I've got this letter P, 2p, and I am adding this -4p to it. So then again, we're going to do the same thing. I can use the commutative property, and I can rewrite it to be 2p plus -4p. The commutative property says we can change the order as long as we're adding, and we won't change the answer. The other term in here is a -6q, so I'm going to put that over here all by itself, and then we can treat this part of the problem exactly like example A. And so 2 plus -4 excuse me, becomes -2p. And as I've already said, we can't do anything else with that -6q, so it's going to hang out here at the end of this algebraic expression. Example C, we have -15. I'm going to look down the line for any other plain numbers, and there's a 3. Again, we can use the commutative property to reinforce that these are like terms, and I'm going to put them together. And that 7z is the only part in this problem with the letter z, so that's over here by itself. I'm going to simplify -15 plus 3. It's going to be -12. And then we have plus 7z. The last example that I have here is letter D. And as I'm looking at this expression, it has 8t and 14, and because there's not a t with the 14, this is all we can do with this expression. So let's move on to the last example here. All right, let's get this last example out of the way here. And this last example takes not just letters, or excuse me, numbers, not just variables, but it kind of puts it all together. As you're looking at the first example, we do have one that has two different variables in it. That doesn't mean the rules change. You still look at the variables. It has an xy, this has an xy, neither of them have an exponent. So these are like terms. They're both going to have an xy, and all you have to do then is pay attention to the coefficients, and you're going to do 2 plus 8 to give us 10y. Again, anytime we're adding and subtracting with variables, nothing happens to the exponent. The only thing that changes is the coefficient. Let's look at example B. I'm going to start here with this negative 3RT, and I'm going to go down the line and find anything else that has an RT. Well, here's a plus 9. And I see that 4R is all by itself, so I'm going to put a different shape around it. Again, they both have RT. Then I'm just going to do negative 3 plus 9, which is what? 6. And we're going to have an RT. Again, we don't change anything about the exponents. And 4R is the only thing in the oval, so we're going to keep our 4R by itself. Example C. I'm going to start with 10x, and so I'm going to go down the line and find anything else that has a 10 or an x here. We have a negative 9x, and we have plus 4x. So because each of these three things has an x with it, take the coefficients. 10 minus 9 is positive 1, and then 1 plus 4 is 5. So we know that we're going to have 5x. Again, keeping that exponent. And then here is 13xy. And we just keep it as is. Now, if there had been another xy in the line, then we would have done the same thing that we've been doing with all these other terms, paying attention to the coefficient and then combining them from there. Last example with this lesson, we have 8RT, and so I'm going to go down the line and look for anything else with an RT. There isn't anything. So then I've got this term here with an S. Oh, and then I've got the 8 plus 8, that's all by itself. So because I have three different symbols here, there aren't any other like terms. This is completely simplified. You can't do anything else to it. Those are examples. So now what I want you to do, where you're done with your lesson, is draw a line straight across, and you're going to write your summary. One of the ways that you can help focus on your summary is to take a look at these questions or statements or sentence starters and talk about the focus of this lesson was. So what is it that I focused and emphasized here? One thing did you learn, or that was emphasized, or that you solidified? An example in your own words, or your own example, not one that's in the previous slides. And then one question to extend your thinking. Maybe it's a question about how can something get clarified, but maybe it's an extension, like a what would happen if, or when this happens, or when I see this in a problem, then what do we do? So there you go, folks, a quick review of combining terms with numbers and variables. Have a great day.